The question is the second question from the monopoly problem set, which is the Cournot Duopoly with fixed costs. So there is a bit confusion about how to write down the best response correspondence. Or actually, it's still the best response function, but you actually need to go through the method I used for finding best response correspondence to find this. So I'll show it here. So in the solution, I provided a shortcut that works for the exam as well. So you don't need to do this, but this is the formal, better way to do it, and this is the way that you should do it for if you are taking, say, ECO206 or something. So the first thing is to write down the utility function as a function of Q1 and Q2. So this is a piecewise function, so let's do it this way. And it's 10 minus Q1. So I'm sorry, I don't want to type the subscript because it makes the computation confusing. But anyways, this multiplied by Q1 minus Q1 and minus 5. So this happens if Q1 is strictly larger than 0, and it's just 0 if Q1 is equal to 0. So that are the two pieces. So remember in class, what we did for the Cournot duopoly is for each piece we find the maximum. So for the first piece is this thing. It obviously looks like a concave function, so let's take the derivative. So differentiate with respect to Q1, you get this, and then you solve for variable Q1. So this is our best response. So this, say, Q star. So the star is very hard to type as well, but let's do it. So Q star 1 is equal to this, and let's call this the interior solution. And there is a boundary solution which is 0 because I said 0 is constant. So Q star, this star looks different, but anyways, Q star 1 here, I call this the boundary solution to distinguish the two. So then the next thing I said is evaluate this original expression at these 2 points. So the original expression is this, so I just copy it down and I literally substitute this thing into each place where it says Q1. So this and this and this, and then I need to simplify it somehow. So let's simplify size. Yes, then it becomes this thing. So what this is this is utility of firm 1 at Q star Q1 star interior and Q2 is equal to this, and simplify to that. And the second one is U1 U1 at 0 and Q2, which is obviously 0. So then we need to make a statement. The first one is larger, so the interior is larger if something happens, if when this thing is larger than 0, right? So when the utility at this point is larger than utility at 0, so this is hard to solve, so let the computer solve this. So solve for variable Q2, so you get expression like this. So it's smaller than number, or it's larger than another number. So, well, maybe the best way to do this is to draw this so that you can see what's going on. So plot this, and say I need domain, so say it's from 0 to 20, then it works. Yeah, so when it's smaller than this number probably is this 9 minus 2 square root 5 stuff, and then or larger than this, which is this 9 plus 2 square root 5 stuff. So in these two areas, this thing is positive. So that is larger, and of course interior if that doesn't happen. So sorry, I said it wrong. So it's boundary if it doesn't happen otherwise. So now we can write down the best response correspondence. Or function, it's actually still a function. So best response function Q2 is equal to, let's use this. So again, remember it's copying from the original interior solution, not whatever the utility is. So we copy this, and then we put it here. So we put this here. No, I don't want this. And this happens if this thing happens. So this, okay, and there should be or in between. And otherwise is 0. Let's just say otherwise. So that's how you write down the best response correspondence or function. And then you do the same thing for the other guy, and then there are four cases, right? Both interior could possibly result in an hash, or one interior and one boundary, or both boundary doesn't work for sure. So basically there are three cases to try, and one of them works. So after you solve them, you see these things need to satisfy these 9 minus or plus 2 square root 5 condition. If it doesn't, it means it's not an hash. I think that's all I want to say. On the exam, you don't need to do that. Whatever I wrote in my solution is sufficient. But the thing is, you need to remember, if there are fixed costs, you need to check whether you want to produce or not. So that's the only thing. But again, this is the formal way to do this.